Okay, so 6-4 is factoring polynomials. Okay, so we have done factoring before. What did we factor? Quadratics. Okay, so those methods that you've previously learned, still important. We still need to be able to factor quadratics. Okay, so you will have to do that at some point in time. Okay, so we have the easy method and the hard method, right? The not so easy method. Fair enough. The soft method, yeah. Soft method. Okay, so I'm going to show you a couple more. This first starts by taking you through like a real-world scenario of trying to visualize why you would need factors, and I'm not going to really go over there. That just talks about the volume of a prism. So I'm going to start with the simplest method. The greatest common factor. It does say mononomial, meaning one term. But we're going to start by simply pulling out the greatest common factor. Okay, so just so you know, anytime you're factoring a polynomial, by the way, if I say polynomial, is everybody on the same page as me? What am I saying? What am I talking about? Multiple terms. Okay, it could potentially be x to the 10th plus a whole lot of other terms. Probably won't be, but it could be. Okay, so you always start by seeing if you can pull out a greatest common factor. Bless you. Okay, so quick example. Let's see if I can find a good one. Oh, yeah, this is the one I like. Okay, question number 4 here. Can you guys see that? Can I pull out a greatest common factor? Okay, so everybody agree that the first term that I can pull out is an x? So I have an x, and if I pull x, what's left over? 3x squared plus 7x. Whoops. I don't like how straight up and down. Let me rewrite that. Plus 4. Okay. Now, I am not finished because I have a linear term and then I have a quadratic. Okay. And you always need to check to see if anything can be factored further. Okay. So do you see the quadratic that I'm left with here? See what I'm talking about? Okay. Can I factor that further? Which method would I try to use to see if it is factorable? The hard method, right? Or, I mean, the not so easy method, right? Let's do it. Okay, so to see if it's factorable, I start by multiplying the first number by the last. So it's 4 times 3. Okay. Are there two numbers that multiply to 12 and add to our middle term, which is 7? 3 and 4. Okay, so that means I would have to rewrite my linear term with what? So the 3x and the 4x, right? So we rewrite the middle term. And then after I write it into 4 terms, what do I do next? I group. So I group the first two, group the last two. Okay, what's my greatest common factor for the first term? 3x. Okay, what would be left over? X plus 1. Greatest common factor of the second quantity would be a 4. And what's left over? Plus 1. Okay, at this point in time, I can look at this and say, oh, this is factorable because why? The two quantities are the same, right? So that means the x plus 1 is one of the quantities. What's the other one? 3x plus 4. Okay, so I'm going to go back to my red one. Now notice there was a piece that was on the outside. What was that piece? That greatest common factor. Okay, you do not lose the greatest common factor. It drops down. Okay, and then I can write my factored version of that quadratic. So x plus 1 and 3x plus 4. Okay, so the goal basically is to get to all linear factors. It won't always happen that you get to linear factors, but that's the goal. Okay. Yeah, or you just factor as far as you can. So if that quadratic wasn't factorable, you would still just say the answer is x times that quantity. So that's somewhat factored. Okay. Are we okay with greatest common factor? That's pretty simple, right? Okay, so there's a few cases here. So you're going to want to write these down. So there are 4 little special factoring patterns. 4 special factoring patterns, and I'll highlight these so they're super easy to see, hopefully. Okay, here's the first one. It's a difference of squares. Okay, so the difference of squares is where you have a squared minus b squared, and that's going to factor into a plus b times a minus b. Okay, so when they say the word difference, where do you think they might be referring to that with that? Subtraction, right? Difference means there's subtraction going on. Why do you think they use the word squares? Because they've been squared, right? Like literally they're squares. So like, what are numbers that are perfect squares? Okay, there's 4. What's after 4? 9. Then 16. 25. 36. 49. Okay, 64. Those are your perfect square numbers. So if you see those numbers on your factored form, that's where you should be getting, oh, that's probably a difference of sum, or difference of squares. Excuse me, a difference of sums. That would be different. Okay, the second one is a perfect squared trinomial. Okay, this one is probably the hardest one to notice, but it's basically the scenario where if you were going to use like our easy method, you know, what 2 numbers multiply to the last term and add to the middle, well, the 2 quantities happen to be exactly the same. Okay, so if they're exactly the same, that's called a perfect squared trinomial. Right, yeah, it's supposed to help you. Okay, the third one is called a sum of 2 cubes, and I'm just going to call this a sum of cubes. So sum referencing what? Addition. Okay, so we've got addition going on, and what is cubes referencing? What do you know about the numbers? They're perfect cubes. They've been cubed. Okay, so what are our perfect cube numbers? What's the very first one? What's 2 times 2 times 2? 8. What's the next one? 27. 3 times 3 times 3 is 27. 4 times 4 times 4. 64. 5 times 5 times 5. 125. And usually they don't go higher than that, which is pretty nice because then you start dealing with some big numbers. Okay, so if you see one of those numbers, that's where you know you're probably using some kind of cubed. Okay, they also have a difference of cubed. The only difference is, that it's a difference. You subtract. Oh, and you type it? Okay, tell me when I can go past this, because I'm going to slide down quite a bit. Yeah, that's how they do definitions. A's and B's. Everybody good? Okay, here we go. I'm going to scroll. Nobody's going to get upset? Okay. I'm going to go down to the bottom here where I have some better examples. Okay, so we'll do a couple of these until we got it. Let's start with number 1. Okay, so what is always the very first method that you try? Greatest common factor. So on number 1, can I pull a greatest common factor?
Yes.
What is the greatest common factor?
X.
X. Okay, so I have an X, and then what would be left over?
X squared plus X.
Minus 12. Okay, so that looks good. Now, am I finished? No. I've got a quadratic, so I have to check. Bottom, bottom. Keep going down to the homework part. Okay, so which method am I going to use to see if this is factorable?
Oh,
Yeah, let's do easy, right? Let's do easy if we can. What two numbers multiply to negative 12 and add a positive 1? 4 and negative 3. So this factors, remember that x is going to drop. So x plus 4, whoops, and x minus 3. Okay, so factorable using our, oh, what did we switch? Okay, it does not matter. The order does not matter. So if I read the answer like x times x minus 3 and x plus 4 and you have it written the other way, they're exactly the same. It does not matter which one goes first.
Wouldn't it be negative 4?
Oh, negative 4, positive 3? No, because your middle term is a positive one. See right here? So positive 4 minus 3.
But when you have a 0.
Wait, what? Oh, if I was going to solve?
Yeah.
Oh, yes, if I was going to solve, but we're not solving today. That's next. You're a step ahead of me. Don't go there yet, or you'll get all your answers wrong. Factoring. Okay, I'm going to do number 3 next. Okay, on question number 3, which scenario do you think it is?
Difference of cubes.
Difference. We got cube numbers. Did everybody recognize 125 right away? Okay, 125 is a perfect cube number, so I should automatically be thinking cubed. Okay, now before I factor this, I'm going to figure out what my A value is and my B value. Okay, so for my A, what number has been cubed to make x cubed? X. Very simply, that wasn't a really hard question. Okay, what is my B value? What number has been cubed to make 125? Perfect. I'm going to say 5 because I'm going to use the difference of cubes. If I want to use a negative, then I have to use a sum of cubes. So make it easier on yourself. Use a definition if you can. Okay, so the definition says A minus B. So what's my first term going to be if it's A minus B? X minus 5. Okay, second term starts out with A squared. So what's my A squared?
X squared.
X squared. And it says plus A times B.
You do 5x instead of x5.
Oh, please do. And then plus your B squared. Plus 25. Okay, so now, am I done? That's the question, right?
Yeah, I think so.
Okay, you definitely want to check and see if you can, but I will tell you, and I will vouch for this statement, because I've tried it. You can never factor the quadratic from a difference or sum of cubes. It's never factorable after that. Okay, so if you've just split a sum or difference of squares, stop. Circle your answer. The quadratic is not factorable. You could sit there all day and try to figure it out. Been there, done that. Okay, let's do number 5. Number 5 is a little trickier. Ooh, no, let's do number... Yeah. Ooh, which one? 5 or 7? 5 or 7?
7.
Ooh, 7. I heard 7. All right, you guys like trickiest. Okay, which one is it? Which scenario? Okay, it's a cube because did you recognize 64? And also the first term is x cubed. Okay, so we're doing a sum of cubes. Okay, so help me out. What's my A? What number has been cubed to make 216x cubed? That sounded kind of unsure. Are you sure about that? That sounded kind of like an educated guess. Not that it's wrong. Okay, what's my b value? What number has been squared to make 64? 4. Okay, here comes my definition. So sum of cubes, first quantity is a plus b. So what's my a plus b?
No,
6x plus 4. Ooh, I noticed something. Okay, second term is a squared.
So 6x
36x squared.
squared.
Minus a times b.
6x
24x plus b squared. Does anybody else notice what I noticed?
Why?
Why?
No,
What?
by 2.
There was a greatest common factor way back at the very beginning. So what does that mean my factors can do?
b.
Okay, so let's say we totally forgot to pull greatest common factor, which we did. That actually was true. Okay, so can we just leave this as our answer? No, it's not totally factored. We have to pull out a greatest common factor if we can. Okay, so let's start with the linear quantity. What's the greatest common factor of 6x minus 4? 2. Okay, so I would pull this 2, and what's left over? 3x plus 2. Okay, now can I pull a greatest common factor out of that quadratic piece? What? 4. Oh my gosh, 4. So if I pull a 4 half, 36 is going to change into 9x squared minus 6x plus 4. Okay, so how do I write this correctly with these two things that have been pulled out? 8. You just multiply them together simply. So this becomes 8 times the quantity 3x plus 2 times the quantity 9x squared minus 6x plus 4. Right, yeah. If you look back at the original one, what was the greatest common factor of the original? 8. We could have originally taken an 8 out of that.
Always shortcuts.
There's always a shortcut, right? So how do we feel about sum and difference of cubes? Everybody okay with that one? That's pretty easy. Okay, let's do, let me see if I can find a good, ooh, whoa, oh my god, that's hard. Ooh, okay. Let's do this. This is the, what method are we on? Let's call this the third method. So you got greatest common factor, you got a special case, and you got the grouping method. Okay, so grouping method. Now, the grouping method is not brand new to you. You actually already know how to do it. You had to do it when you were working with the hard method. Okay, so we're at this step right here. What do you notice? How many terms do you see here? 4. The grouping method only works if you got 4 terms. So it's really super easy to identify. Okay, and guess what your very first step is? To group. Like I said, mathematicians are not creative. We're going to go ahead and group right away. All right, so what's my greatest common factor off the first quantity? X squared. Okay, what's left over? X plus 8. What's the greatest common factor off the second quantity? 6. What's left over? X plus 8. And at this point I go, yes, I know I did this right.
It's x squared 6.
Right, those two are the same. So x squared plus 6 and x plus 8. So now I got to look at this and be like, ooh, I got x squared plus 6. Can that be factored further? If it can be, yes. But can it? That's the question of the day. What are our methods that we could check it? There's two of them, right? Okay, we know it's not the trinomial one, right? The perfect trinomial one. One of the definitions up there was difference of squares. Is it a difference of squares? Clearly, because there's a plus sign, it's not a difference, right? Okay, our other method we could use is the easy method, okay, which says, are there two numbers that multiply to our constant and add to our linear term? So are there two numbers that multiply to 6 and add to 0? No. So, conclusion, it is not factorable.
Like, get those problems out of the entire page and stuff like
I guess you could. I don't know about an entire page, but yeah.
that.
I didn't see one that was a difference of squares. Do you guys want me to do one of those so you can see it? Let me do one that's kind of like on the assignment, because I noticed this is a little tricky. Let's see. I don't know what number we're on. We're on number 5 now. We're going to do 4x to the 6 minus 16. No. 49. Yep. Sold. Okay, so this is a little bit tricky to identify. Okay, and I kind of already spoiled the surprise, but which one is this? Okay, it's a difference of squares. Okay, now why is it not a cubes one? 49 is not a cube number, very good, and neither is 4, right? 4 is not going to get us anywhere. Both of those numbers are perfect squared numbers. Okay, so for the difference of squares, what's my a value here? Okay, what number has been squared to make 4x to the 6th power? 2x to the 3rd, very good, it's just like half. What is my b value? What number has been squared to make 49? 7. Okay, so the definition of difference of squares is simply a plus b and a minus b. So what's my a plus b? 2x cubed plus 7 and 2x cubed minus 7. Easy peasy. How do you guys feel? Pretty good? The hardest part is recognizing which one, but if you remember your squared numbers and your cubed numbers, that's a big helper. Okay.